Today we're looking at lesson 6.2, which is a way of solving a system of equations. For lesson 6.1, we looked at graphing the equations to solve. Now we're using substitution to solve. So there's a three-step process for substitution. The first step is to, when necessary, solve at least one of the equations for one variable. And what that would mean, if I saw this equation here, x minus 3y equals negative 9, then I would solve for either x or y. And what I mean by that is I'd get the variable by itself. So you can choose which variable you'd like to solve for, whatever is an easier process. So in this case, I would choose to solve for x, since it's already by itself in terms of the number next to it. And all I'd have to do to get it completely by itself on the left side is to move the 3y over to the other side. And now I've done step 1, is what they mean. So you're going to have two equations, and you need to make sure one of them is equal to either x or y before you start the other two steps. The other two steps are, step 2 would be to substitute what you just got from step 1 into the other equation to replace that variable, and then you solve the equation for the variable. And then step 3 is to substitute the value that you got from step 2 into either equation for that variable and solve for the other variable. And then you're going to get an x coordinate and a y coordinate, or x value and a y value, and you're going to write that as a ordered pair. So we're going to do this together. So step 1 says to solve one of the equations when necessary for one variable. Well, if you look at the first one here, it's already solved for y, so we don't need to do step 1. Step 2 would mean to take what's equal to y, so in this case the 4x minus 6, and substitute it in for y into the other equation, and that would be step 2. So I would now have in the other equation 5x plus 3 times 4x minus 6, because I'd replace the 4x minus 6 with the y, okay, because it represents y from the first equation. And we have that equal to negative 1. And notice now that we have all x's in this equation, so we can actually solve this equation for x. So we're going to have to distribute. Combine like terms. And now get the variable by itself. So that I get for my answer, x would be 1. Now it says step 3 is to take the x equals 1 and substitute it into either equation for x and then solve for y. So whatever is easier. I would choose the first one. That's my preference. So if I plug in 1 for x in the first equation, I would get for y negative 2. So my answer would be 1, negative 2. We're going to do a couple more of these. This one, if you notice, one of them is following step 1 already, so we don't need to do step 1 because one of them is already equal to y. So we're going to take what's equal to y and substitute it in for y into the other equation. So 2x plus 5 times 3x plus 10 instead of y equals -1. And we're going to solve like we did the last one for x. So this is my second step. And I'm going to solve for x, continue to solve for x. And I would get x equals -3. Then I'd take x equals -3 and plug it into either x value in either equation to be able to solve for y. So again, I'm going to choose the one that's equal to y because it's easier. And I'm going to plug in -3 for x to find out what y is. So that would be -9 plus 10. So y would be 1. And I need to write my answer as a ordered pair, so -3, 1 would be my answer. And we're going to just keep going. In this case, we actually do need to do step 1, so we need to solve for one of the variables. I'm looking at both of them, and it looks like the second equation would be easier to solve for y, so I'm just going to have to move the 3x over to be able to do that. And then I've done step 1, which was solve for one of the variables in one of the equations. Now we have this equal to y, so we're going to take that and substitute it in for y into the other equation to be able to now solve for x. So I'm going to solve for x. And notice we've done the same thing. This is now the third time. So the same process is followed every time. And now I combine like terms. And I'm going to divide both sides by 19 to get x equals 4. Now I take for step 3 and plug in x equals 4 into either of the equations. I'm again always going to use the one that's easier, so in this case I'm going to use the one that I had to change for y. So I'm going to take the x and plug it in for x there. And I get 12 minus 13, so that would be -1. If I write it as an ordered pair, I have 4, -1 as my answer. We'll do one more like this, where I'm solving for one of the variables. In this case, it looks like the first one would be easiest to solve for x, so I'm going to solve for x for that one. So notice that you can choose which variable you want to solve the equation for. So now I have one of the variables equal to the equation by itself. So now I can take x equals, and I need to put the 3y minus 9 into the x for the other equation. And now I'm solving for y first. So notice it does not affect which ones you solve first. So y would be 4, and then I can choose which one I want to put the y in for. So I'll choose the one that I changed to equal x. So x equals 3 times 4 minus 9, or 12 minus 9. So x would be 3. And my answer would be 3 comma 4. And we're going to continue doing this process, and I'll show you something different here that's going to happen, but I wouldn't know ahead of time, so I would continue to solve this the same way. Notice that one of them is already equal to y, so I don't need to do step 1. I'm going to take what's equal to y and substitute it in for y into the second equation. So 2x minus, and then 2x minus 3 equals 8. This is actually like a -1, so I'm going to distribute it. So I have 2x, minus 2x plus 3. Now 2x minus 2x actually cancels itself out. When you have that happen in your solving process and you get a statement that is false, so 3 equals 8 is not true, I can stop the process and just say no solution in this case. And again, I'm going to do one more. I need to follow step 1 and make one of these equal to y or x. So I'll just do the first one equal to, let's say, y. So I'm going to take the 4x, put it over here. Divide everything by -3. And even though I have fractions, I still do step 2, which would be to take what's equal to y and put it in for y into the second equation and solve for x. So again, notice when I'm going to combine my variables, they cancel each other out. 8x minus 8x is going to be 0. So I'm left with -2 equals -2, which is a true statement. So in this case, I still can stop solving, but my answer is going to be infinitely many solutions instead of no solution. And we have one more problem here where we need to come up with 2 equations and solve to be able to answer the question. So in this case we have, as of 2009, the New York Yankees and the Cincinnati Reds together had won a total of 32 World Series. It says how many World Series had each team won, so that means each team needs to have a variable to represent how many World Series they've played. So we're going to do, let's say x is going to be Yankees World Series, and y will be Reds World Series, and they have a total of 32 that they've won together. So we're going to write it like this. X plus y would be 32. If we go back and keep reading, we have the Yankees had won 5.4 times as many as the Reds. So we're going to put it equal to x, and it's 5.4 times as many as the Reds. So we're going to do 5.4 times y equals x, and that's going to be our second equation. Now notice step 1 has us solve for one of the variables. Well, one of them is already solved. It's equal to x by itself. So we can take the 5.4y and put it in for x in the second equation. So 5.4y plus y equals 32. That's going to be 6.4y equals 32. So I divide by 6.4. And I get 5. And then I take my 5 and plug it into either equation for y. I'll just pick the first one. So x plus 5 equals 32. And solve for x. So x would be 27. So in the end, the Yankees have won 27 World Series and the Reds won 5 World Series. And that concludes lesson 6-2.